All right, today's lesson is on comparing and ordering rational numbers, and there's a few common sense things that the kids need to look at. One, to save themselves some time, and then two, just that they should recognize these things right off the bat. For example, number two, you're comparing two rational numbers here, and one of them is negative and one of them is positive. So I told the kids today, it doesn't matter what the number is. If one of them is negative and one of them is positive, then it's obvious that the positive number is going to be greater. So yes, they can compare those decimals pretty easily, but a common sense thing is just to first look at the signs so that you don't have to do any extra work that you don't need to do. You can see the same thing over here. 8/11 and negative 1/3. Positive is always going to be larger than a negative in this case. The ones that require us to do some work are ones that we have to change a fraction to a decimal to compare, or a decimal to a fraction to compare. So for example, if I wanted to compare number 5, let's do number 5. If I wanted to do negative 3.72 or 3 72 hundredths and compare that with negative 3 9 tenths. Some fractions, or in this case a mixed number, some are very easy to change. Our whole number is 3, and 6th graders for the most part should know when we have a base 10 fraction that's talking about the 10th place. So in this instance we have 9 tenths. So it's very easy for students to see how to compare these when they change it, especially if it's an easy fraction to change. I also ask them that if to fill in all the place values, it can help you compare. So we can add as many zeros as we want to after the 9, because we have 2 place values here and 2 place values here. Sometimes that helps students see that even if we're not looking at the whole numbers, we can compare the decimal portion to know which is larger, which is smaller. In this instance, we're talking about a negative number, both numbers being negative. So negative 3.90 is farther away from 0 than negative 3.72. So because it's a negative number, negative 3.90 is less than negative 3.72. So very easy to change over a fraction that has tenths or hundredths or thousandths. The ones that might cause us to have to do a little bit more thinking would possibly be something like number 1, where we have a mix of a decimal and a fraction. And students may not be able to convert that very easily. So I would have them think about it this way. Negative 4 and 4/25 can very easily be changed to a fraction that has a base of 100, because I know that 25 times 4 gives me 100. Whatever I do to the denominator 25, I must also do to the numerator. So 4 times 4 is 16. So now I can look at this as negative 4 and 16 hundredths to the hundredths place. And I can easily compare that with negative 4 and 12 hundredths. So by changing the fraction to a nice easy base 10 fraction, I can switch it to the decimal that I need really quick. I know that negative 4.16 is further away from 0 than negative 4.2, so I'm traveling that direction on the number line. So since negative 4.16 is further away, we're talking about negative numbers, so it's actually smaller, because negative 4.12 is closer to 0 on the number line. Okay. Ones that they may need to convert to decimals might look like number 4. They may not know how to get a common denominator for ninths and eighths, and it may be easier for them to just use our division method to change both of these fractions into a decimal. There's a previous video that I've made that would help you do that, but it would look something like this. We are taking 7 and dividing it by 9. Make sure they set it up correctly. The numerator is what we are dividing. Under the division symbol is where we want the 7. We know that 9 can't go into 7, so we know that we're dealing with a decimal number. 9 goes into 7 0 times. 0 times 9 is 0. We bring down, and we have 70. Now we try to figure out how many times 9 goes into 70. Students may know, they may not know. They may know a fact that's close, but they've got to do something to check. For example, they might have to make a list. They might have to start like this and make a list. I hope that they don't have to start like this always, but if they need to start there, they can. Okay? So they would continue to go, 9 times 2 and 9 times 3. They would continue to go on in their list to find numbers that are close to 70 without going over 70. Maybe they need to do all the factors, maybe they don't, but we're getting a little closer. $63 is pretty close. 9 times 8, we just went past. So we are looking for 7. It goes in 7 times. 7 times 9 is 63. We subtract the difference between 70 and 63. They can borrow if they need to, but they should also be able to know that this is 7. 9 can't go into 7, so we have another 0 to bring down. And it looks like we may have a repeating decimal. 9 goes into 70. Again, we already know that's 7 times. 9 times 7 is 63. And it looks like we have a difference of 7 again. We're going to need another 0. And what we found is that we have a repeating decimal. So the more that I do this, the more 7s I will get. And the students we've worked on repeating decimals, we know that that can just be written as 0.77 repeated. It's going to keep going. So, since we're talking about a negative number, negative 7/9 is actually negative 0.77 repeated. So, we've switched one. Let's switch another one to a decimal. Let's take our negative 5/8 and use our division method. 8 does not go into 5. We know we're going to be dealing with a decimal. 8 goes into 5 0 times. 0 times 8 is 0. We subtract. We're right back where we started. 8 goes into 50. Again, we can make a list, but I know that 8 times 6 is 48, and that's as close as we can get. 48, not 40. I do my subtraction. 8 cannot go into 2, so I bring down another 0. 8 can go into 20. It can go 2 times. 2 times 8 is 16. And I subtract. My difference is 4. And now I'm pretty sure that I'm almost done because I'm noticing this is going to give me 40 when I bring in that 0 down. And 8 goes into 40 exactly 5 times. So again, I'm talking about a negative 5/8. So I need to make sure that I keep that negative, so it is negative 0.625, negative 0.625. It is much easier for me to compare decimals than it is to compare these fractions. I can even add this extra place value if I want to. Now, actually that wouldn't be a 0 because we have a repeating decimal, so you have to be careful of that. But either way, let's forget that for a second. Just looking at these, I know that 7/10 is more than 6/10. Actually, it's less because we're negative. So negative 7/10 is further away from 0 than negative 6/10 is. So just this place value alone tells me this number is farther away from 0. That makes it less. So these are some of the questions on the homework. I'll do one more video for a different type in just a minute, but hopefully these can help you compare and order rational numbers.